Hi, this video is to cover all the review problems I gave you for homework and to help you prepare for the quiz that's coming up. So the instructions on number 8 were describe the transformation, graph the parent and its transformation, determine domain, range, and y-intercept. All right, so if this is our parent, right, what are the changes here? Go back to our a b to the x minus h plus k. So the only change here is we have a k of -6, right? A is 1, which is no transformation. H is 0, which is no transformation. So if I wanted to graph this using my calculator, I could, right? Going to graph both of these on my calculator, but K means we had a vertical downward shift of 6 units, right? So the only thing that's changed on this is the fact that the horizontal asymptote, instead of being at y equals 0, which is the parent, is now at y equals -6. Okay, so for the parent, I could come over here for the parent, right? I could even make myself a little XY table. Could look at my table and say, all right, 0, 1 always works. 1, 10. So 0, 0, 1, 1, 10. So it looks like this. And my horizontal asymptote for the parent looks like this, right? Is y equals 0. This one just moves down 6 units. So if I made a table for the new graph, it says 0, -5, and 1, 4. So 0, -5, 1, 4. So it just moves down 6 units. Okay, so here is my horizontal asymptote. My domain, as it is for every exponential function, is all real numbers. My range, right, is from -6 to infinity. Okay, let's look at 12. 12 says, state the domain and the range, identify the new values of the reference point and the asymptote. All right, so first I'm going to identify A, H, and K. A is 0.5, H is 1, K is 2. So this is growth, and your reference points for growth, right? These are the reference points for the parent. They transform into this. You will be given this. So let's calculate and draw. So I know that my asymptote is y equals 2 because k equals 2. So this is my horizontal asymptote. All right, my first reference point is h, a plus k. -0.5 plus 2 is 1.5 or 3/2. So 1, 3/2 right there. My second reference point is h plus 1, right? And then it's a times b plus k, which is -2 plus 2. So my second reference point is 2, 0. Well, got everything I need to graph this. Got my asymptote and my 2 reference points. My domain, as always for exponentials, look like that. My range, now it's a reflected, right? Goes from -infinity up to 2. Remember, k is instrumental in the range and the horizontal asymptote. All right. I might have missed one. Well, here's 18. So 18 is where I'm giving you points and an asymptote. I'm giving you the graph, and you need to write the equation for this graph. And remember, our equation is Okay, so you need to identify the points that are given, which one of these relates to 0, 1, and which one of these relates to 1b. So notice if this is growth and I reflect it, now it looks like this, doesn't it? This point reflects here, and I'll do this point as a triangle, it reflects here. So this first point here is the 0, 1 point, right? This is -2, 3.7, and that corresponds to H, A plus K. All right. Now, one thing we know for sure from this graph, K equals 4, because there's my horizontal asymptote. Once we matched this point up, right, H is the X value of this. So I know that H equals -2. So I need to find A. So 3.7 equals A plus K. K is 4. So 3.7 equals A plus 4. I'm going to subtract 4. A equals -0.3. So I have everything to write the equation, don't I? G of X equals A. They tell us in this, in 18, I gotta go back to 18. They tell us that B is 10. They give that to us. So that's 10 raised to the X minus H plus K. All right, the second point, this -1, 1, which equates to H plus 1, AB plus K, we can use it to check things, right? If -1 is H plus 1, we're just checking. -2 plus 1 indeed works. So H is correct. Well, we didn't make any math errors. Now we're going to say, well, if I take A times B plus K, so A times B plus K, 4. That's -3 plus 4 is 1. That works. So we were able to verify our A, B, and A, H, and K. So this is the correct equation. All right, 3.1, here's a story problem. Sue has a lamp from her great-grandmother. It's appraised and it's worth $1,000. The appraiser tells us that it's going to grow in value by 8% a year. In how many years will the value of the lamp be 2,000? So the growth equation, when we have something that's appreciating in value, looks like this, where A is the original value, right? And it's going to grow at a rate of 8% in decimal form per year. So here's the growth function, isn't it? When will the value of the lamp be 2,000? So here's our good old horizontal line that we're going to graph, and we're going to find an intersection. So I'm going to my y equals, and I'm going to graph both of these. So the first one is 1,000, 1.08 raised to the x, right on your calculator. This is x, and my second one will be 2,000. Now, in every one of these story problems, we had to adjust our window. So I'm going to say, let's take it to from 1,000 and just a little bit above 2,000. And then here, I'm just going to use 0 to 20 because I'm really not sure what it should be, but I'm going to try 20. All right, so my y min is 1,000, my y max is 2,100. And graphing it, oh, we'll definitely see an intersection here. So this growth graph looks like this. The horizontal line's coming across here. We're going to be able to find this intersection. All right, so I'm using my calculate menu to find the intersection. It says when x is 9 years, the value will be $2,000. right? So there's 13.1. Let's look at 13.2. The difference here is that this is now decay, right? Whereas B is between 0 and 1. So let's identify we're going to identify the transformations. Well, A is 3, H is -3, K is -6. So this is a vertical stretch, right, by a factor of 3. This is a shift to the left of 3, and this is a shift down of 6. Trying to make sure we look at the directions here. 4 is, describe it, and then give the domain and range. Well, guys, K is important. It tells us the horizontal asymptote, doesn't it? So your horizontal asymptote is y equals -6. If you graph this, it's going to be something like this, and it's a decay. It's doing something like this. So domain is always all real numbers. Range is going to be from -6 to infinity. And our horizontal asymptote is -6. Y equals -6. Now, number 8 says, graph the transform function, describe the domain and range. So we're going to graph this function using the reference points. So the reference points for decay look like this. Right? They're slightly different. So you got to know when you're doing decay what you're looking at. All right. So A equals -3, H equals -2, K equals 7. So I'm going to figure out the reference point. So the first reference point is H, A plus K. So the first reference point is -2, 4. Right? Now, 5, 6, 7. Here, now we're mixing up. Here is our horizontal asymptote, right? Okay, our second point is going to be H minus 1, so -1. A over B, B in this case is 1/2, right? Plus K. All right, -3 over 1/2 is the same as -3 times 2 over 1, so that's -6. -6 plus 7, -1, 1. So -1, 1. This is a reflected decay. So let's look, our decay normally looks like this. So reflected should look like this. So let's see what I did. Oh, this is -3. What am I doing here, guys? H is -2, minus 1 is -3. So this point isn't there. It's right here. So this looks like there is your reflected decay. Okay? Now, again, here we're given points. So let's do this. If our reference points are here and we reflect it, I'll make this if I reflect it, this point's here, this point's here. So this is 0, 1. So the point that corresponds to 0, 1 in this is here, right? -4, 1. That corresponds to the 0, 1 point, which is H, A plus K. All right, we know number 10 right, that K is 3, H is -4, A plus K equals 1, A plus 3 equals 1, A equals -2. So far I have things I need, but what I don't have is B. So the second point, -5, -3, corresponds to H minus 1, A over B plus K. So let's check this. -5 equals H minus 1. H is -4, so -5 equals -4 minus 1. That works. Now we got to find B.